The Research and Technology Park, as the name might suggest, is about bringing companies that are really interested in research and technology onto the campus of the University of Waterloo for the purposes of collaboration. My name is Mike Pereira, and I manage the David Johnston Research and Technology Park at the University of Waterloo. The park is about 20 years old now, and as the name suggests, it was founded by David Johnston, who at the time was the president of the University of Waterloo, was really passionate about this idea of building out a research park that would be able to create space for companies to be on campus. Since that time, we've grown to 10 buildings, just about 1 million square feet, and when everybody's in, there's about 4,500 people working here. So it's a pretty busy place a lot of the time, and there's a lot of really cool stuff happening. So the ecosystem around the Waterloo area has become so much more robust, and the park has really kind of grown along with that. What I think is starting to really change, though, is the types of companies that were here. 20 years ago, it was mostly software, mostly ICT. Now we're seeing a lot more hardware, a lot more life sciences, and that's changing the way we think about the kinds of spaces that we need in the park. And it's also changing how I'm starting to think of what we could use the built form of the park for, to do different types of innovation. And so we've started to see some really cool projects come out of that over the last 5 years. As the ecosystem has grown, what we're hearing from a lot of companies is it's not always easy to find opportunities to test ideas out, especially when they require something more than just an office space. So a great example is something like an autonomous vehicle. If you want to test that in maybe beyond a test track environment, a closed, completely secure environment, but aren't ready to transition to right out in the middle of downtown with lots of pedestrian activity, there's a need for some in-between space there, and R+T Park's infrastructure can kind of help with that. And right around as I was starting to pitch this concept internally, the city of Waterloo reached out and said, so we've been having some conversations with an e-scooter company, and we want to be able to run a pilot project, but it's a little bit tricky to do it on the public streets. Would the R+T Park be an option? Because we have 5.5 kilometers of private trails. So we were able to come forward in partnership with the city to set up this e-scooter pilot, which was the first one in Canada. There was no real precedent for this, no understanding of how do we do this, what are the rules, what do we need to think about? And we were able to start establishing some base rules, some base governance, run a pilot project, which was really successful. We had 18,000 trips in the first 8 weeks on these scooters, which was really cool. And it also gave us a ton of really interesting data about where people were going, how they were using them, which then informed a whole lot of other interesting projects.
If you're trying to understand and move people away from auto reliance, and you're trying to manage a system that's complex, has lots of moving parts and pieces, and you're trying to plan for future changes, you need to have data to understand what's going on currently in your system and set targets for how you want to move that system to a different state. The majority of trips that we make on a daily basis are short. They're typically under 5 kilometers or even less. And so researchers and city officials would say, well, this is a real interesting opportunity to see how people react, and will they leave their cars at home more often because they have this new mobility opportunity.
And now today, the region of Waterloo is just launching 1,000 e-scooters and e-bikes throughout the whole region, built off the findings from this initial research project. So it's a phenomenal example of how we tried something that we didn't exactly know was what was going to happen, and it actually led to real-world policy change. Right around the time that the e-scooter pilot launched, Professor Elizabeth English in the School of Architecture started building a dock out in the stormwater pond. And she was like, well, after Hurricane Katrina, I did a ton of research around what happened to housing and what could we do? It turns out this is also a big problem on a lot of First Nations reserves, which are built in floodplain areas. And so when the areas flood, the houses get damaged. And could we do something different? So she started building this floating foundation. They call it the Buoyant Foundation, which is also the name of the nonprofit that sort of is doing a lot of this research.
I started to think about, what if we could make the house float while the flood is there and then come back down and be an ordinary house again after the flood water goes away. Basically, it's a platform that's fitted out underneath to have buoyancy so that it will float, and also to have a system to prevent it from floating sideways. I was trying to put it in a natural environment where I would observe fluctuations in the depth of the water so that I could install it on the ground and then be in a situation where a flood would come and that would lift the amphibious installation in the way that I've described, and then let it come back down. We looked around for some place that would allow us to install on an existing body of water, and stormwater retention pond number 2 is our savior.
We're filming here in Evolve 1. This is the first office building in all of Canada that is certified zero carbon and net positive energy. That means the building, through sustainable zero carbon means, generates more energy than it actually needs. So the whole building has been designed from the ground up for monitoring and for building a culture in which everyone is positively contributing to the building's performance.
The big story is the building itself only uses 1/3 of the energy of a normal office building. Pardon? Yeah, that's right. It's 1/3 of the Canadian median. So now we're talking about reducing that 1/3 to even smaller amounts from there.
We did kind of some pilot research and also looked at the literature in terms of what can we do in the building from a psychological perspective to encourage people to be more sustainable, but also promote their well-being.
Good design is always step number 1. So having an accessible staircase in the atrium invites people to use it. So the good news is there are a high number of people using that. And when we invited our students to count the users periodically, we get to see how excited are people to use this radical technology, a stair step instead of the elevator.
We put in a bunch of indoor environment sensors that measure temperature, humidity, noise level, air quality, and also movement. So we connected the performance data from the building and show at any given time how much energy is being produced by the solar panels, how much energy is being used, and so how much of a net positive impact do we have at any given time, as well as over time.
And 5 years later, we recently released a University of Waterloo study that showed not just the design of the building, but the behavior of the people was what actually kept it on track. So it's not just about engineering systems, it's about ensuring that everyone in the building is positively working towards the same end goals that the building was designed for. So there's a lot of excitement in Ontario and really around the world about autonomous vehicles. However, it's actually pretty difficult to just let an autonomous vehicle loose on a public street. It's really not an easy thing to do. There's a lot of regulation and multiple levels of government and a lot of hoops to jump through. We were approached by a startup emerging out of the University of Waterloo's Autonomous Vehicle Research Lab about could we maybe run some testing in the park? And there was a really specific project that they approached us with. So the company's called LoopX, and they were partnering with Rogers around 5G. And how could we use 5G to improve the connectivity between the vehicle and off the vehicle sensors and edge computing in the cloud? The goal being, you want the vehicle to stop as fast as possible when it detects something, and you don't want the reason it doesn't stop very quickly to be signal delays between the vehicle and something else.
So I think we are solving a really complex and challenging problem. Ordering takeout food is really expensive, and the main reason is significantly increasing labor cost and those delivery fee. And I realized that this may be a good chance, an opportunity that we can use autonomous driving and robotics to reduce those costs. We see a lot of chance that this kind of repetitive work can be replaced by robotics, since companies in the transportation area are facing significantly labor shortage. With a fleet of robots for food delivery, we can reduce the cost of delivery fee. We even delivered a few hundred food orders in partnership with a food delivery platform and several restaurants.
Yeah, speaking of autonomous vehicles, there's a really exciting research project at the University of Waterloo. It's being led by Dr. Amir Kajipur, who's a leader around the world in autonomous vehicles and drivetrain systems. And they've created something they call the Watonobus, because Waterloo Autonomous Bus, the Watonobus, which is basically a driverless shuttle. And it's been piloting around the university's main campus a little bit over the last while. The great thing about the Watonobus is it's fully electric and it's very sustainable. So if we can get a regular autonomous shuttle service running between North Campus and Main Campus, it'll solve a lot of problems for a lot of people while also allowing us to do world-leading research.
We now have a fully operational shuttle on the campus, and that has become a focal point of developing many technologies that now we are trying to apply it in different applications in autonomous farming, autonomous underground mining, and autonomous mobility in indoor operations. The shuttle that we have can handle 12 people. And in terms of the size, is the same size as a maybe full-size passenger van. The intersections that we have are not controlled by traffic lights. They are all stop, meaning that when the shuttle gets there, it needs to know who was first, who was second, and then based on that, make a decision. It needs to handle many pedestrians. So I'm very, very excited and proud of what my team has done in making the shuttle fully autonomous and operational.
At R+T Park, we often talk about this idea of bringing innovation out of the lab and into the world. This, to me, is at the perfect intersection of those two things. This is both the lab and the world. So how do we get things moving along a pathway where they can actually create some real-world benefits? And I'm excited that we're actually starting to see that pay off.